AMCASH, Advanced Materials Characterization Simulation.
With the ERD funding, MCASH project is able to have some unique facilities for material characterization at the School of Metallurgy Materials, University of Birmingham. As part of the MCASH demonstration series, this presentation will look at some case studies to show what we can achieve with these facilities, in particular to determine the defects in forged components. My name is Mingshi Wang, a technical officer of MCASH project. The first case study is to use the Scanning Electron Microscope to get micrographies of a fractal surface. The second one is to carry out chemical analysis on the contamination found in a forged steel component. And the last one is about non-destruction test to observe the cracks by MicroCT. The sample of the first example is a forged steel bar, which failed during service. The image in the middle is the overview of the fractal surface obtained by SEM, which is quite similar to optical image. However, with the SEM, we can go to a much higher magnification and get more details. As shown in the image on the right, some cracks with the size of only several microns were observed along the grain boundary, indicating that the failure is due to intergranular cracking. With this confirmation of the failure mechanisms, the further development of this forged component shall be focused on how to strengthen the grain boundary. The EDS is a chemical analysis technique used in SEM. Features as small as 1 micron or even less can be determined, such as the contaminations in forged components. As you can see from the image on the left, cracking was previously found at a particular position of a forged steel component. If we zoom into the area where the cracks were found, some black inclusions were observed on the outside surface of this component. With the chemical analysis by EDS, like the mapping of elements shown here, the black inclusions turn out to be silicon oxide. As the oxide is more brittle than the base material, such silicon oxide is believed to be the nucleation site of the cracks. With this information, the customer confirmed the contamination was from the forging mode, and this problem was easily solved by a more frequent cleaning of the mold surface during manufacturing. Last example is about MicroCT tomography analysis. MicroCT is similar to the X-ray test in hospital, where the X-ray will penetrate the sample, leaving a 2D image. For MicroCT, with the rotation of the stage and the specialized software, it can offer a 3D reconstruction. The image in the middle is a 3D reconstruction of a forged steel sample with a crack on the surface. The 3D reconstruction allows you to get the cross-sections as you want. For example, we can have the cross-sections from XY plane and YZ plane as shown in the image on the right. From these cross-sections, the crack is confirmed to be not only on the surface, but also grew into the material about 2 millimeters. Thank you for listening. If you have any interest in using any of the facilities we have as a part of the MCASH project, then feel free to contact me directly or contact the MCASH project team.